So we obviously worked through a lot of the examples in the beginning. We talked about how the goal is to find the angle that meets whatever trig function that we have. And all right, so let's just do one quick example before we get into the multiple angle ones, okay? And let's talk about what's the difference between the instructions on the left and the right. So if I do just solve, then what kind of answers am I looking for? Good. I'm looking for the answers that are on my natural full circle for sine and cosine. So sine and cosine, I use the full circle. And then I add 2n pi to it. And if it was tangent, I would be looking for my from 0 to pi. Oh, there should be a bracket on the 0. 0 to pi portion of the circle plus n pi. On the right-hand side, if it said solve on the interval of 0 to 2 pi, you're using just your natural circle, the full circle for all the trig functions, but you don't have to add anything to it. All right, so subtract the 2. 4 cosine x equals negative 2. Divide by 4. Cosine of x equals negative 1/2. So I'm looking for everywhere on my full circle, because it's cosine, that my x is negative 1/2, and that occurs at 2 pi over 3 and 4 pi over 3. If my question's direction said on the interval of 0 to 2 pi, I'd be done. That would be my answer. But if it said just solve, then it would be 2 pi over 3 plus 2n pi and 4 pi over 3 plus 2n pi. Any questions on anything we talked about yesterday? So up to that point, we also did factoring. We also did substitution if they are two different trig functions, that kind of stuff. But it's important to understand the difference in those directions. We're good, yes?
If in the equation it said 4 tan plus 2,
yep,
it'd be plus n pi?
And you only look at the top. So let's say it said tangent, let's say after you solved it, it said tan of root 3. Then I would only look at the angles in the top, and that's pi over 3. Okay. And then I add n pi. And that's because it repeats every half circle, which is every pi. So I don't have to do pi over 3 and 4 pi over 3. That's like saying the same thing. Yeah. Okay, then we get into something called multiple angle equations. And sometimes the directions will change, and so you'll know that's what it is. And sometimes it will still just say solve, and you have to identify that it's a multiple angle equation. And the way you spot them is something is attached to the x. So it's either going to be multiplied by the x or divided by the x. Not squared, because squared we already did. Squared, you just square root both sides, putting that plus and minus. But anytime there's something attached to the x. And so what we do with these is first ignore it and find the angle with the interval. And then you take and isolate the x. So at the end of A, I'm going to divide everything by 4. At the end of B, I'm going to multiply everything by 3. And there's two different kinds. So we're going to do the first one, just solve without the interval, because that's actually when it's easier this time. So where is sine 1? Pi over 2 plus 2n pi. And if it just said sine of x, that would be my answer. But it doesn't. It says 4x equals that. So now I have to isolate the x by dividing by 4 or multiplying by 1/4. And I get x equals pi over 8 plus, this goes in twice, n pi over 2, or 1/2 n pi, same thing. And that's how my answer looks. So not only is what's next to the x going to alter the angle, it's also going to alter the interval. Questions so far? Okay, so now I'm going to do tangent. So tangent of x over 3 equals 1. Where is tangent 1? Because that's where I start. Think tangent, we do the top. Good, but remember tangent, you just do the top. So just pi over 4 plus n pi. And then this time we divided by 3. So instead of dividing, we're going to multiply each term by 3. And that's your answer. Yeah.
So we wouldn't use
Not for tangent, because tangent's only from the top. And then it repeats every n pi. All right, so honestly, I don't think that part's that bad. It gets weird after this if the instructions were different. So make sure we understand that part so far. We're good? Okay, so just be sure you don't do anything with that 4 until you already find the angle. Once you find the angle, then you would divide by 4, or you don't do anything with the 3 yet. So now let's say that same question had the instructions that said on the interval of 0 to 2 pi. Now normally if that happens, I don't do this part first. I don't find the nk pi, or the 2n pi, sorry. But because we alter that interval, you have to do it first. So if it said on the interval of 0 to 2 pi, you still find it the way as though it wouldn't. You would still do this whole process. I would find the angle in which sine is 1, which is pi over 2, plus 2n pi. I would then divide by 4, and I'd get this. But that's not my answer. I actually have to find the specific angles that fall between 0 and 2 pi that start at pi over 8 and then increase by intervals of pi over 2, because that's what n pi over 2 would be. So I start at the first one, which is pi over 8. That's one of my answers. Then I add the updated interval to it. So pi over 8 plus n, we're going to make 1. So we're going to add pi over 2. And I change this, multiply by 4, multiply by 4. This becomes 4 pi over 8, and I get 5 pi over 8. And I check to see if that's on the interval. Is 5 pi over 8 between 0 and 2 pi? Yes, so I keep it. Then I do it again. I take and I add 5 pi over 8 plus pi over 2, which would be 4 pi over 8. And I get 9 pi over 8. Is 9 pi over 8 between 0 and 2 pi? Yes. So I keep it as an answer. And I do it again. 9 pi over 8 plus 4 pi over 8. And I get 13 pi over 8. Is 13 pi over 8 between 0 and 2 pi? So I have to include that as its answer. And then I take 13 pi over 8. And I add 4 pi over 8, and I get 17 pi over 8. Is that still on that interval? No, so I'm done. These are the 4 angles that would give you a sine when you multiply by 4. So sine 4 times that angle is going to be 1. Sorry? When you're adding this interval, yes. Technically, we're changing it from 1 to 2 to 3 to 4 if you keep adding to the first one, but we just keep adding that interval. Yep. All right, so now look at B. So again, if it had said on the interval of 0 to 2 pi, I would have done this exact same thing. And I would have gotten 3 pi over 4 plus 3n pi. And I would take that first answer, which is 3 pi over 4. And then I'm going to add the interval into it. Now the interval this time is 3n pi. We're going to make n 1. So I take 3 pi over 4, and I'm going to add 3 pi to it. Is that number going to be between 0 and 2 pi? No, if I add 3 pi to something, it's already bigger. So that is done, and the only answer that works is 3 pi over 4. Not x over 3. So not tangent of x over 3.
Oh, okay.
Does that make sense? If it was tan of 2x, let's just say that. Let's say it's tan 2x equals 1, right? I would find the angle again, which is pi over 4, because it's, well, let's make it pi. Yeah, that's one. It'd be pi over 4, and 2x would equal pi over 4 plus n pi. Then I would divide by 2. So multiply by a half, and I get x equals pi over 8 plus n pi over 2. So now pi over 8 works, but then I'd have to do pi over 8 plus pi over 2, or 4 pi over 8, and 5 pi over 8 is going to work. And then I have to add.
Okay.
Does that make sense? It depends on if you're adding or if you're multiplying or dividing from the beginning.
I didn't realize that you're just making like the end of like taking the
You're
end
just
out.
doing one because that would be one interval, and then you just keep adding it and keep adding it and keep adding it until it's too big. So the next one would be what, 17 pi. So these 4 angles would also give you 1 for tan of 2x. Questions? Because I feel like multiple angles with a given interval is probably the hardest thing in this section. It's probably the hardest thing in the last couple sections. But it's the most confusing. So are we good? Yes? Okay. You've got time.